So we're going to start topic 4 where we're talking about forces today. So you're going to be turning to your orange packet, page 16. And Newton's first law of motion states, if the net force acting on an object is 0, that object maintains its state of rest or state of motion at constant speed in a straight line. So before we can really understand his first law of motion, we have to start with some of the terms that are in here to be sure we understand them. So we're going to start with force and net force in order to start being able to apply Newton's first law of motion. So a force is a push or a pull, and that is the simplest definition we have, and I expect you to have that memorized. So the units of force are newtons, and they are abbreviated as a capital N. And when we write the word newtons, we also use a capital N because it's named after Sir Isaac Newton. It's important to state the direction of a force because a force is what we call a vector, which we'll talk more about later. But for right now, it's going to be really important to know if the force is directed up or down or right or left. So for right now, we want to be sure that we are including the direction of all of our forces. And a Newton is defined as a kilogram meter per second squared. And this will make more sense as we continue to work with it. And some examples of forces written correctly, we've got 30 newtons to the right, or we've got 30 newtons drawn with an arrow to the right. So these items you need to memorize. We're going to be working with these for the majority of the rest of the term, and you need to have this memorized. So a force is a push or a pull. They're defined in newtons, which is a kilogram meter per second squared, and you always have to state the direction of a force. So net force is defined as the overall forces acting on an object. And you can see in this first top box here, we've got an arrow to the right and another arrow to the right. And those mean that you're going to add those two forces together because they're both acting to the right. In the other example here, we've got one force that's pointing to the right and one force that's pointing to the left. So they're actually opposing each other. So you're going to subtract those two forces when you're trying to figure out what the net force is. So let's consider a few examples. So we've got here this first one, number 1. So we've got a 50 Newton force acting, pointing towards the right, a 30 Newton force pointing to the right. Many times when we start drawing these, we would draw them on the same side of the object, but this could be like somebody pushing like a refrigerator from one side and somebody else pulling it like with a rope. So it doesn't matter which side of the box it's on when we're determining what the net force is, but it is important to notice the direction that the arrows are pointing. So here we've got 50 newtons to the right, 30 newtons to the right. So when we add them together, we're going to get 80 newtons to the right. And the one on the bottom, we have 30 newtons to the right and 10 newtons to the left. So our net force here is going to be 10 newtons to the right. So when you're writing these, you're going to want to be sure you include the capital N for the newtons and an arrow pointing in the direction of the total net force. Let's do 2 more examples. So here we've got 3 forces acting on it. We've got 5 to the right, and here we show that there's 10 and 20, which is a total of 30 to the left. And so you can figure out what that one is. And in this case, we have 20 newtons pointing to the right, 20 newtons pointing to the left. So in the first one, we've got 25 newtons and it's going to the left. And in the bottom, it's 0 newtons, and we don't need to write a direction because it's nothing. It's 0. There really is no net force. So a couple of tips. When you're doing the net force, you're going to add all the forces together. consider forces to the right and left separately from up and down. So if we had something that had forces up and down, you're going to consider those as a set, as well as the ones to the right and left as a set. And we use the same convention for positive direction as we do when we are in math. So like on the number line, the positive direction is over here to the right, where the negative is to the left. And same with up is positive and down is negative. So later on, we'll be indicating some of these as being positive or negative. However, you can also write right and left and up and down. So you have a practice sheet here on page 17, and the answers are on the bottom of the page. I don't anticipate you're going to have any issues with this because this is actually a fairly easy topic. So there is a short assessment for this on Google Forms for you to do. And when you're ready, go ahead and you can click on the link for that. It's here in the PowerPoint. It's also on your student checklist, which you have accessible on Google Classroom. And when you have successfully passed that assessment, come on back and watch the next video.